You won't believe.
What happened? Oh my God. Was that from the last exam? 84 out of 90?
Uh-huh.
Congratulations, Katya. That's so
Thank
good.
you.
But what was the
And I got the highest score.
Oh, you got the highest score?
Mm-hmm.
God, that's so good. Oh my God. Wait, what was it on again? The chairs, the one that you
Mostly chirality, yeah.
chirality, RS and stuff like that.
Yeah.
Oh my God.
He had us label like, yeah, it was crazy. Even without, he dropped our lowest question. Even without that, I got a 90.
Right. Were there like enantiomer, diastereomer questions, mesomolecule questions, constitutional? Oh my God, that's so good.
Yeah, the only one I like really kind of messed up on was the very last question about carbocations. I think I like blanked out on it.
Oh, right. That for A, right? Okay. Oh, yeah, it's not a carb anion. There's no negative charge there.
I know. I was like, oh, wait, not sure what I was doing, to be completely honest. I was like, I don't know.
Uh-huh.
But this question, this is the one I was telling you about where I
Hmm.
had no idea. The name of it is 4-methyl cyclohex. Okay, cool. I understand what that means. Cyclohexylidenia acetic acid.
Or methyl.
Look at that name.
Oh, wait. And then, is that the one that you told him in class? Are you supposed to know that name? And then he drew the structure in class?
Yeah. So then he gave us the skeleton, yeah. And then I drew the skeleton is over there. And then I drew
Uh-huh.
the two enantiomers, and then I gave my explanation, and I got a 10 out of 10 on it.
Uh, wait, let me reconnect the thing to my other Wi-Fi. Okay, hello.
Oh yeah, I can hear you.
Yeah. Wait. Can I see that structure again?
Yeah.
For the thing that you drew?
I was like close with my original drawing, but not
Uh-huh.
quite. I can
Oh,
let me
that,
make this
that
a
molecule was
PDF.
chiral or achiral? Oh, yeah, no chiral centers. That's good. That's good.
Yeah. And
Right.
then I said because like none of them are in the same plane, and he was like, ah, yes. And then one of them he had the incorrect name for the compound, and I
Uh-huh.
wrote that on there, and he put yes exclamation point.
He got so excited.
I know. I was like, let me. I'll send this to you.
Okay,
I'll
yeah,
make
yeah.
it in a
On
PDF.
Google Drive,
And then
right.
I have a quiz to do by the end of tonight with a bunch of not mechanisms. Oh my gosh, he wants us to know how to do the mechanism on the exam for the ozone, the
Oh, the
mercury,
ozonolysis?
and the hydrobromation.
Oh my God. He wants you to know the mechanism for all those reactions? No note card? Oh my God. That's crazy.
Yeah,
So what
yeah.
I would do if I were you is like draw out the mechanism on paper or your iPad
Hmm.
until you can do it without looking at the notes. Like the
Yeah,
first two
just
times you
over and over again.
yeah, right. And then to help you do that, talk to yourself and explain why each arrow is going there, like why this arrow is attacking that things, and it helps stick more, right? Instead of just brute force memorizing like the arrows, like the direction of it, right?
Hmm.
Like what's the nucleophile, what's the electrophile, what's getting attacked, and why?
It's like so many steps. Oh,
I know, and that's so mean. Like what the heck?
I know, because I asked him, and
What
I
if he's
was
just saying
like,
that and
he was
then
like, anything I've written on the whiteboard is fair game for me to ask you the mechanism for. I'm
oh
like,
my God,
oh my
yeah,
Lord.
I would still know it just in case.
Oh, well, yeah, no, and he wrote them. He did.
Oh my
He
God,
did. Yeah, we didn't finish chapter 8 on Friday. We finished
uh-huh,
it on Monday
yeah.
for the exam on Thursday. It's great. It's just fantastic.
Yeah.
Send this to you. Yeah, if you have like the mechanisms written out, because I took pictures of what he put on the board.
Yeah.
But if you have like I think it's like those three that are like the harder ones.
Yeah. Let me send you this file that I have for my
Yeah.
118B notes. All the alkene reactions are there, like hydrogen, oxidation, oxymerization, demeritation, ozonolysis, all the reactions and mechanisms are included in that document. Let me share that to your email.
Yeah, that's perfect.
Mhm.
Okay, there. That is all of them. I will send this to you right now so you can see my test. I
Okay.
don't think there's anything I should ask for points back on, but We could look at it after
Yeah,
we do the quiz.
wait. Oh, the quiz due tonight, huh?
Yeah.
Let's
It's
see.
just the products though, no mechanisms.
Okay. Yeah.
Thankful for that part.
Uh-huh.
I have a paper already to like write out all the mechanisms on, so I can just like look at it after I like write them down a bunch.
Right.
This is what I need here.
Did you post the quiz what you have so far on the drive as well?
Oh, yeah. Let me put that.
Let's see. Katia.
Everyone had their finals, huh?
Yeah, they had the finals last week. This new summer session, like I had to say no to like new people who wanted tutoring because you know how like my chiropractic school is getting like kind of busy. Like I need like time to study for myself, you know.
No, yeah.
Uh-huh. Let me get your email here. Oh yeah, the 3 midterms I had today went well. Like it went better than the exams I had last week for sure. Because I gave myself
That's so good.
yeah, and I'm so happy. Let's see, let me share
Yay. Hopefully you get 93s too, or better.
Let's see. Oh, we get the scores right away because it's digital online multiple choice. So I got like 92, 90s, 90%. There was one that was
Nice.
lab station where you have to like rotate around stations and then like write it down. So that's the one I'm waiting on right now. But I'm pretty sure I got 90 plus
Oh,
on that one
crazy.
too.
Nice.
Yeah. Let's see. Okay, I just shared with you the document
I
with the
just saw it, yeah.
yeah.
Good thing is, I mean, like you made it now, grades are a little less important.
Yeah, it's less important. Yeah, I just need to see like to pass. I don't need like an A or
Literally, at this point, C's get degrees. You're fine.
yeah.
That's what I tell myself. I'm like, once I actually get into vet school, nah.
Yeah. You don't need to worry about anything anymore.
Finally be that person. Yeah. So I think these are all the reactions are the ones in blue. And then what I'd started writing down the products for is in black.
This is the quiz right here.
Mm-hmm.
Okay. Let me import to this. Boom. Yeah. Okay.
We actually did mass spectroscopy or mass spectrometry, whatever. I already forgot the
Are
difference.
you more familiar
Today.
with that now? Like the mass spectrometry stuff when he went over it?
I mean, not really. But I mean, we did that in lab today, and I was like, oh, isn't that big peak in alcohol? And he's like, yeah, the big peaks in alcohol. I was like, yes. And he's like, so once you do the experiment, that shouldn't be there anymore. And then we were the first ones to do it.
Yeah.
Didn't mess up today, thank God. And he ran it, and ours was the only one that worked. The machine stopped working after ours, and the alcohol group wasn't there. And I was like, yes.
Oh shoot! So you actually did the mass spectrometry in person in lab?
Yeah.
That's kind of crazy. What the heck?
I know, but he's like, the people before us messed up a part of the machine, so it wasn't working very well in the heat, I don't think, for the rest of the group. So they all took a picture of ours.
Dang, that's so good. Ooh, Yulin Bayer-Villiger reaction, ozonolysis,
Permanganate,
permanganate.
hydroiodic,
Yeah, zinc, copper, oxidation, mercury. Okay, let's do it like this. Let's 1, 2, 3, 4, 5, 6, 7.
Yeah, he just kept writing. I was like, oh my sir, how many do you want us to do?
1, 2, 3. Yeah, a lot of alkene reactions that he wants you to know.
Yeah, oh my gosh, we started on alkynes today.
Yeah, alkynes are going to be very similar to alkenes. It's just 2 times of the reaction, right? But the same mechanism, but 2 times. So know your alkene reactions really well, and then you'll do well on the alkyne chapter.
Thank goodness alkynes are like next week. So
Yeah.
that's good.
And not
We're like approaching the end. I'm like, okay, one last weekend of horrible term. Yeah.
Alkenes and alkynes, you're gonna get a head start because when it's in B, that's the beginning. Like up until week 4 or 3 actually for alkenes and alkynes.
That's good. Oh yes. So I'm gonna have like a head start.
Yeah, like a big head start.
Awesome. Love
Yeah.
that. It's always nice to have a break at the beginning of the quarter and be like, that's how I felt with this class. A lot of it was from like intro chem. And so I
Yeah,
was
Gen
like,
Chem.
okay, cool. Yeah.
Yeah.
I know what an
But
electron is. No.
electron, proton, neutron.
Yeah. I
Wait, did you go over alcohol reactions though? And ethers?
think so.
Wait, like Williamson ether synthesis, PCC, A. Jones,
Maybe not.
BH4, LiH4, because that's the very end of one ECA.
Yes. Lithium.
Lithium
We
aluminum
did.
hydride,
Yeah.
right? With
Uh-huh.
carbonyl.
I think, yeah.
What
Oh,
about PC?
I wish I had like taken my notes a little bit better. I didn't realize just how many of these I was gonna have to be writing down. Otherwise, I would have done them like more like same facts for each, but instead they're a little all over.
Oh, like for the reactions?
Yeah.
Yeah, I know. Let's see. Some of these alkene reactions I don't recognize, like the zinc and the HI one. Like I don't know what the heck that is.
Oh, no, that's not good.
Let's see.
The zinc and the no, it's zinc and copper.
Zinc and copper. Zinc and copper.
Yeah.
What that one?
Or you mean the iodine?
Yeah, that one too. The zinc and the iodine one.
Oh, okay. Ooh, let me make sure. Oh, let me make sure the slides are up there on the doc on the Google Drive for you.
Sure. Oh yeah, yeah. Let me go check your lecture sites on that too. On
Let me
page.
upload them and then they will be there.
Right. See.
What was the last thing that I uploaded here? Class resources, lecture notes. Okay, I
Class
did chapter
resources.
7. Oh, okay, so 6, 7, and 12 are there, but I'll upload the rest of them just so that I have a head start.
Uh-huh. And this is
Oh,
chapter 7, alkene, structure and reactivity.
yeah, it kind of just all goes together. It's like 7 and 8.
Oh, 8 is the reactions, right? 7 is just the introduction to what alkenes are, I think.
Oh, yeah. I don't know. It's all turned into mechanisms in my head now.
So, yeah. Uh,
No, not that, not that. Stop it.
let's go down though. Yeah, like which one's more stable? Alkene more substituted. Oh yeah, this reaction here. Electrophilic addition HX. We went over that last time. Addition of like Markovnikov's rule, more substituted, less substituted.
Yeah, I feel like I could totally do the products. I'm just like a little worried because I have no idea which mechanisms he's gonna ask us for, and I'm like gonna have to memorize them. But then what if he changes the reaction a little bit? Like I'd like to think I understand it well enough
Right,
that I could
right.
like fix it. I answered a lot of the questions correct in class,
Mm-hmm.
but it was so funny. I walked in late today, and then it's like, "What can I use to cleave this double bond to make 2 carbonyls?" And I'm like, ozonolysis before I even like sat down, and I
Oh
was
my
like,
god, yeah, yeah. Once you hear the cleave word or the cut part, ozonolysis, the scissors reaction.
and I was like, and people probably think I'm like looking at the answers, but I didn't even have my stuff out yet.
Yeah, and then you already know how to predict the product without looking at the mechanism. Just cut it, put the oxygens in the middle.
Yeah, most of them I've like I feel like we got a good handle on. I just need to like study and then hopefully get
And
the mechanisms
practice,
down.
like a lot of practice. Like
Yeah.
OChem, like you'll notice that this is all practice rounds to make it like realistic,
Oh my God, I spent the whole weekend doing homework. I sat for so long, I hurt my hip.
Oh my god, your hip?
Yeah.
Oh my
My dad
god.
had to like adjust my hip.
Did your dad adjust you?
He did. He fixed it. I swear it felt like I pinched a nerve, like I couldn't walk.
Oh my god.
It was bad. It was like all of Saturday and like the beginning of the day on Sunday, most of Sunday, just doing the homework. It was
Man, you're
like
putting in the
show
work.
all 17 isomers, E and Z for this compound. And I'm like, stop.
Did you upload the chapter 8 notes to the
I'm
class?
trying to figure out how I did it last time. It's like not wanting to
Yeah, while you do that, I'll look up the reactions that I'm not familiar with here.
okay, that's good. Good
Let's see,
stuff.
let's see.
Okay, here I'll just do it from here. There we go. But maybe this will work. Because it's like the folder like doesn't want to show up in my thing, which is like so weird. What account is this one?
Oh.
Okay, it is that one. I don't like the sound of that, Brian. That's freaking me out.
This is interesting. Oh. No, I have seen this reaction before with the KMNO4, but it's just a different reagent, right? Because yeah, the common one that I've seen is this right here. So KMNO4 is gonna be the exact same. I'm gonna put it as a dash like this. Dash osmium tetroxide, OSO4.
And yet he showed us that one as well.
Oh really? The osmium
Yeah.
one?
Uh-huh.
Yeah, that's good. That's good. So no both. No osmium tetroxide and a KMNO4. They'll do like similar things. Let's see. And then
Chapter. Okay, I guess I can do it this way. Oh, crap. Okay, I'm gonna have to move that into the actual folder. Okay, whatever. I'll do that in a second. Upload. Browse. Chapter 9. Upload. Chapter 10. Okay, and then I just want to put.
okay.
There we go. I think I fixed it.
RCO3.
Yeah, I opened the Canvas notification while I was driving and I was like, oh
Yeah.
my gosh, I got a 93. And then I looked at the spread and I was like, oh my gosh, I got the highest score.
Dang.
And then I was like, I can't tell my friends. They'll
Did they
all
ask
hate
though?
me.
Did they ask like how'd you do?
I told a couple of them,
Uh-huh.
but not my lab partner because she got like a high 70.
Oh yeah. But did she ask though? Like did she ask like how'd you do?
Yeah, and I was like, I did all right. Better than I thought.
Yeah. Different reactions. When he went over the KMNO4 reaction, did he go over temperature like below room temperature, above room temperature?
I think he said like primary and secondary carbons will only react under specific conditions.
Only
Like
specific.
that, like with the temperature stuff, I believe. Let me look. I actually have this written down.
HiO4. That's for carbohydrates.
Maybe not. This is strong nucleophiles. Maybe that was for alkylation of acetylide anions. I think that's what he was talking about, that temperature part for. There's just like I feel like there's so many, but a lot of them are super similar, so I need to like not stress. But
Yeah, like they
I was
could be
like,
grouped into like the reactions, you know.
yeah.
Right.
Okay, wait. Alcohol, no, okay. And then for alcohols, he said rate of reaction in primary and secondary is slower at higher temperatures. Is slower and at higher temperatures. That was for alcohols to alkyl halides, though. So I don't think that was talking about for manganate.
So you did go over some alcohol reactions, alcohol.
Yes, but that was chapter 10.
Chapter 10.
So yeah.
Oxidation, hydration.
So that's not on the exam.
Hydration, oxidation.
Yet.
Right. Okay. So let's go over the first one here. Right.
Okay.
When you see this carbon here that almost looks like a carboxylic acid, but it's not. It's a peroxy acid because like you see this really weak bond between the two oxygen atoms here. Like when you see that bond, that's very weak and reactive.
Okay.
Right. And then a common peroxide acid that you might see is MCPBA. Right.
Oh, okay.
What that will do is create an epoxide from an alkene. So this is our alkene right here. Our epoxide will look something like this. Right. Where I'm gonna make this
forget
epoxide.
what it looks like.
It's like a three-membered ring where the center is the oxygen atom.
Ah, yes. I hate
like
that because there were so many of those on the homework.
Uh-huh.
And I was like, also, he said that answer key sucks at showing mechanisms. So I'm like doing what I think is correct. And I'm like pretty sure that I'm right. And then I go to look at the answer key and I'm like, what is this?
Yeah, like what's going on here, huh?
Yeah.
Let's see.
Okay.
So that's how you predict the product. Like to form this right here, where the alkene carbons are the carbons of the epoxide right there. Right. For ozone analysis, we really know how to predict the product here. We cut the double bond in half and we put oxygens in the middle like that. Right. And once we do that, we should get these kind of products there, which if you draw out, you should get full credit because this is a formaldehyde, which you could draw out like that and like rotate it to make it more aesthetic, but that's the same thing right there. I would draw out the hydrogens explicitly for the aldehydes to make sure your TA, your grader, or professor knows that this right here is an aldehyde, right?
Okay.
Because
I put
aldehydes.
H2C and then like double bond O. Is that okay? Like it's not line bond structure, but I just put like that.
Yeah. H2C double bond O. Yeah, that's acceptable as well. Right.
And then double bond carbon with 2 methyls. Yeah, perfect.
Right.
Yeah.
Right. Okay, so
wait, so is that the answer for the first one?
The epoxide.
Yeah.
Right, it's the answer for the first one, and then we didn't have to include wedges and dashes here because there's no carbon center. This carbon here has 2 methyl groups, right? And then there's no carbon center. Wedges and dashes are optional. You can make everything flat, right? This carbon here has 2 hydrogens, so there's no carbon center. But if there was a carbon center, then you would have to include stereochemistry. And an important part about this reaction is that this is syn addition, meaning that the bonds attached to the oxygen are on the same side. The same side. Syn addition, right?
That's starting to make more sense now. Okay, so as far as what's happening to the molecule, that's the first carbon with the 2 hydrogens, and then that's the one with the 2 methyls. So basically, the oxygen gets added across the double bond to the carbons,
right,
on the same side.
Yeah, and then the oxygen specifically that gets added is this oxygen right here. Like this oxygen I'm gonna highlight in yellow is the oxygen of the epoxide.
Okay.
Right. And then the mechanism of this reaction is included in the notes that I sent you through email. So if you review those with the arrows, then you see all the arrow pushing mechanisms for there.
Okay, perfect. Yeah, I was like trying to ask him questions and like get a comprehensive list of like which ones I exactly need to know the mechanism.
For the mechanism, yeah. He seems like one of those professors like, oh, everything's fair game.
Kind of, and that was like not my initial impression, so I was like, my dude.
I know. Like, I like those professors who like tell you exactly what's gonna be on the exam. Like I have one of those professors right now in my chiropractic like school, and then he says, "Oh, what do you guys want to get tested on? Let me know." And then he'll start it, and then like we know exactly what's gonna be on the exams, which is so.
Oh, good. And then it is. That's nice. Yeah. He doesn't like fake you out.
yeah. No. If he fixes out, oh my god, because our exam for that is next week, so I'm just gonna trust him and study those things. That.
Yeah, and then if not, be like, "Hey, man, you didn't say this was gonna be on the exam."
Yeah. Right.
Okay, so for that one, and then the permanganate.
Yeah, the permanganate. This is going to create a. Let me write this down.
Carbon dioxide, is that correct? That's what I had in my notes for terminal primary carbons. It would make
primary carboxylic acid.
Yeah. Let me find what I'm looking at here. So
yeah, that's the one with room temperature. So yeah, we're assuming this is in room temperature. Over oxidation to ketones or carboxylic acid, right? Think of it as similar to Cole's analysis.
Here we go. Yeah, and then I put if primary carbon, it makes carbon dioxide.
Right. Let's say this carbon right here is on the left side, which is the carboxylic acid, OH, H, and then the cleavage of the double bond is right there. This carbon on the left side is going to be a ketone, like that, right? Imagine cutting this double bond in half, like ozonolysis, right? Put double bonds in the middle, like this, right? Like what we did here earlier. But this one, think of it as a stronger version of ozonolysis, right? Ozonolysis would just cut the double bonds and not affect anything, right?
Okay.
But KMNO4 is a stronger oxidizing agent, which means that for terminal and primary carbons, they will over oxidize all the way down to the carboxylic acid, right?
Okay.
And then if it's at the terminal end, the specific carboxylic acid you form is called formic acid.
Right? Okay, because it's like formaldehyde.
Right,
but
with the
it's
hydrogen
got
R group. Right.
Okay, and there's no carbon dioxide because he said that for primary carbons it'll make a carbon dioxide.
Carbon dioxide.
Yeah, and the one on the left is a primary carbon.
Oh, primary. Wait.
Because it only has 2 hydrogens bonded to it, but maybe he meant. No, that's still primary. It has to be double bond.
What? Where is this part in his notes? Like which lecture? Chapter
Oh,
18?
he
Chapter
said
8?
it. I wrote it down.
He said that. Let's see.
Yeah, let me look on the exact slide.
KMNO4.
Did I write down the slide?
Yeah.
Let me see, because my friend did that too. Not necessarily saying that that's like correct, but
Is it terminal?
Did you find it? Oh yeah, here it's on the reaction on slide 43. It has it making carbon dioxide with the CH2 on the right.
Slide 43. Okay. 43. Carbon dioxide. Oh, okay. Let me go over this reaction more in detail.
Okay.
Right. Let's say, how do I want to call this? Let's call this substrate of the alkene. And I say the carbon is let's do that. Carbon attached to 2 hydrogens. And then the product. Right. This carbon here is going to be the carbon of the carbon dioxide. Right. Let's say we had this carbon attached to 1 R group, 1 H. Like that.
Then it makes the carboxylic acid, right?
Right. This would create the carboxylic acid like this. Wait, let's cut that. Yeah, so this would be oxygen R.
And then OH, right?
OH, right. The OH would substitute the H in this case. Right? Where the C is that C right there. And then let's say.
And then for the other one, like the oxygen is just essentially substituting the 2 H's, right, for carbon dioxide?
The oxygen here is.
Oh, for the top one.
Oh, the top one? Yeah. The oxygens here are substituting the 2 H's here. Where the oxygens here are double bonded to that carbon right there. Like that. Okay. Right. And then for this one here, where it's secondary, attached to 2 R groups, it's going to form a ketone. Right. Where this carbon here is that carbon right there. Right. And this is for the alkene reaction with first step KMNO4, second step acid workup. Any kind of strong acid, hydronium ion or H2SO4, H2O plus or H2SO4. Right.
Okay.
And then the what we predict the product is similar to ozone analysis in that we cut the double bond in half, right? And then it's a little bit more involved because depending in ozone analysis, we just cut it in half and put the oxygens in the middle like that.
Yeah.
Right. For this reaction, we do the same thing, cut it in half, put the oxygens in the middle, but we also have to look at the carbons of the carbonyl, right? If it's attached to 2 hydrogens, 1 R group or 2 R groups, we have to transform them into these specific products here, right? We have to over oxidize them.
Right.
Make sure they have no hydrogens because all of these products here, they have no hydrogens attached to the carbonyl carbon. No
okay.
Attached to it. Right. So if we go over here, right? So it should not be this formic acid. It should be carbon dioxide because this substrate right here, if we cut it in half, is attached to 2 hydrogens.
Right? On the left, yeah.
This substrate right here, right? The carbon attached to 2 hydrogens on the left. That should be the carbon dioxide product right there. Right. Okay. So when you're studying these reactions as well, try making up diagrams, flowcharts, tables.
Oh yeah, I've got a paper all prepped for a chart. Like half and half. I'm gonna like fold it over, look at one side, make sure I know the other side.
Yeah. Right. And also like the different properties of it, like is it syn addition, anti-addition? What's the sneaky stuff? Like does it involve a hydride shift or something?
Aldehyde.
Like aldehyde. Right. And also another thing is tricks to predict the products, like ozonolysis and this K-4 thing. We cut it in half and put oxygen in the middle like that, right? Like little notes like that to help you remember.
Yeah, for sure.
Yeah,
I know. So like that's just like stuck with me. Like I know the ozone one now. I'm like, but the mechanism.
Oh yeah, the mechanism. That's a different story. That's a repetition thing.
No, I'm like, why would you do that to me?
I know.
Okay, so we've got so carbon dioxide and then the 2 methyl groups. Yeah.
Yeah. Right. The carbon here, oxygen, 2 methyl groups, ketone.
Yep.
Right. Where ozonolysis, we see that we still have the same ketone here, but in the ozonolysis part, we have a formaldehyde. Right. That's not acceptable for the K-4 because K-4 is a stronger oxidizing agent. It will get rid of those hydrogens and put oxygens in there. Right. So like carbon dioxide. Yeah. Right. Okay. HiO4. What is that reaction? HiO4.
I don't even know, man. Let me make sure I didn't miss anything.
So this one here, alkenes can be cleaved by hydroxylation to a followed by reaction of. Oh, so this is reacting with diol, like 2 alcohols. So the reactant here is not.
Let me make sure I have
supposed to be.
Let's see, emotional. No, literally all he wrote for that one was HiO4.
And did he start from the alkene or did he start from a different reactant, like 2 alcohols?
Yeah, I know, right? Isn't that just supposed to be with diols? That's what I was looking at in my notes.
Yeah.
I have HiO4 cleaves diols. And then, it says, but then I put primary alkene with ozone forms formaldehyde or aldehyde. Well, duh, I know that. But
okay, let me summarize this reaction based on what I see here. Right. So this right here is gonna have a vicinal syn diol reacting with HiO4. So these are the reagents you recognize for this reaction. Water and a protosolvent THF. The product that you're gonna get.
What even is THF? Can I just ask?
Oh yeah, THF is some kind of like structure like this.
I asked my friend too, and she's sending me her answer. She said she wrote no reaction because it's not a diol, but I'm not sure if that's right.
Yeah. It's supposed to be a diol for this reaction, but if it started from an alkene, no reaction would happen.
Okay.
No reaction. Right. It has to have a diol, 2 alcohols that are cis. Wait, let me look at the structure of THF for you. THF structure. I'm thinking.
I know he just starts like throwing in these random letters. I'm like, what is OAC? What?
OAC. That's actually important for the mechanism. Wait, like because that's involved in the mechanism.
which
the
I'm
OAC
gonna
part.
have to figure out.
I know. Right. But for the THF here, like ignore that. That's not involved in the mechanism. That would not interfere with the reaction.
Okay, good.
Yeah.
Yeah, because that's actually part of the mercury. That's why it matters.
Oh
The
yeah,
OAC.
yeah.
Okay.
One of the weird words you see in time and time again with the practice.
Now I'm like, what is even going on here, my dude?
And then this is gonna create let's see, how do I word this? Carbonyl, two carbonyls, two dicarbonyl, two carbonyls.
I sent the permanganate one to my friend, and she said that makes so much more sense. And I'm like, perfect.
Oh, this table here.
Yeah, no, I sent her the answer for the one we're doing, and yeah.
Oh,
right, like, oh my gosh, that makes so much more sense.
Yeah. You should also send her this table as well to like reinforce the stuff.
Oh, I totally will. Yeah, I can take our picture too. That was a horrible picture I just took. There we go.
Oh wait, she might not understand what this means on the left side, right?
I think she'll get it. If she asks, I can explain it to her.
Yeah. It's like when you cut it in half and then you do those things. Yeah.
We know what the squiggles are.
Squiggle. Like, what does that squiggly symbol mean? Okay, so I'll show you some different kind of examples here. Let's say we have the cyclohexane, and we have a diol here that are vicinal to each other. Vicinal would mean adjacent. Think of it as adjacent
they're
next to each other. Yeah, right, next to each other. And then syn, think of it as cis, the same side.
I like that.
Cis.
I like that.
Diol, two alcohols. Di meaning two, ol meaning alcohol.
Yes.
Di, two, all alcohol. So that's how you could like break it down and understand what this vicinal diol is. Okay. So if that's a wedge, this would also have to be a wedge right here. And let's react it with.
I mean, that's not chiral.
This, yeah, this is not chiral. What is it specifically? What is the name for this molecule? There's a specific name for this.
Oh, then you want me to name it?
Oh no, don't name it. Let's see. Are there chiral centers here in this molecule? Let's start with that.
Oh, a meso molecule.
Yeah, meso molecule. Yeah. Because there are chiral centers, two chiral centers, and a plane of symmetry.
Exactly.
Right? If there's a plane of symmetry, then this is a meso molecule here.
Now I picked up what you're putting down. At first, I was like, "Wait, what?"
Yeah, I didn't know how to like question it or ask it because it was like, what is the stereochemistry of this? Like in the enantiomers, isomers, but there's only one of them. You can't compare it with anything else.
No, yeah.
Right. Meso is just referring to one molecule.
Yeah.
Right. So to predict the product here, make a cut between the carbons holding the alcohols.
Mm-hmm.
Right.
And then those add the carbonyl.
Yeah.
Have it in my notes.
Add the carbonyl, right? The carbon that was attached to the alcohol is now the carbonyl.
And it looks really weird.
Yeah, it looks really weird, right? But I'll show you a tip on how to draw it more aesthetically if you want. We can number it 1, 2, 3, 4, 5, 6. Our longest chain is 6 carbons long, so 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. At carbons 1 and 6, we have the aldehyde. So we just put the aldehyde at carbon 1 and carbon 6. Great. More aesthetic. Gorgeous.
Amazing. Yeah. Just number it and redraw it.
Yeah, number it and redraw it. Right. It helps.
Does it have to be a ring for the diol? Or could it be like, yeah, it does, huh? Or no?
Let me think of one. No, it does not have to be a ring because you'll learn in 118C, carbohydrate sugars. Wait, so you can have something like this with the Fisher projection.
I don't have to take 118C.
Oh, you don't have to take 118C for grad school, huh?
It's recommended. It is.
It is.
Here's what I'm gonna say in my application. I'm minoring in Spanish. I didn't have enough room in my schedule to take that and graduate in 4 years.
Right,
That's my
right. I
excuse.
know. And I know
Because
some.
if you take 8, you only have to take A and B. It's such a load of
Yeah,
crap.
I know. That's what I heard about vet schools. It's like kind of confusing. Some vet schools accept it, some vet schools like don't accept it. So
Yeah.
it depends on what vet schools you're applying
And
to.
Davis screws over its undergrads. Like if you come from any other school and apply to Davis, it's like great. But
Yeah.
they need to make an 8C
And 8C
if they want us to like
yeah.
like I don't get the purpose. They're like, "Oh, if you take the 8 series, A and B is considered a full year. But if you choose to actually take the 118 series, you have to take all 3 because all 3 are
Oh.
offered." I'm like,
I know. Really? Like even if it's not your major, like does your major require it? It doesn't require 118C, right?
no, it does
Yeah.
not.
So I don't think you need to take it then. Then if
Neither it doesn't. So our major doesn't require physics,
uh-huh.
Chem 2C, or 118C or like C to
C.
graduate.
Oh, right.
But I already took Chem 2C because I need it for vet school because it's required to get in. Physics is
Yeah.
required for vet school, not required for a major. And then, Chem is up to
Yeah.
you because it's recommended.
Yeah. Because in the 8 series, 8A and 8B, you don't go over spectroscopy, spectrometry at all. There's no IR, no mass spec, no HNMR.
How nice.
No, but then you're doing more than you need to know for this.
Because I want to be able to apply to Texas.
Texas. Oh, yeah.
And they require, it's not even like 118 or 8. It's just the number of units you get for it. Because I need like 8. And if you take 8, then you only get 6 units.
Oh, right. Yeah.
Because the first one's only 2.
Uh-huh.
And it's only required 1 lab, and I'm taking 2 labs. I'm like, whatever. Right. Okay, sorry for this.
No,
so it does not have to be.
It doesn't have to be in a ring, but in the examples he did give you, they are in a ring, so it's less complicated that way. In the structure that is linear, right? Mm-hmm. Something else goes with it. Let's say it makes it carbon dioxide. Yeah, it's more complicated if it's open and linear, but he didn't go over that, so let's not worry about that.
So it only reacts with a diol in a ring.
In a ring for this class.
Cool. Awesome.
In a ring.
That's fine. I can cut it off there. That's all good.
Yeah. don't worry about the open. It's still possible, but don't worry about that.
Okay. So for that one, no reaction because it's not a diol. And then for the zinc copper.
Did he mean to have a halogen in there somewhere like X2? Because if there's X2 there, then there would be a reaction.
Probably. Let me look.
Like BR2 or Cl2.
My friend loves the chart I sent her. Let's see for the. Oh yeah, so this has he put next to it the plus CH2 I2. Yeah, that's I2. Next to that arrow.
Okay.
My paper.
Yeah. So this right here, when you see zinc, copper, and CH2 I2, that's gonna form a very similar to an epoxide, but it's just gonna form a cyclopropane. So a 3-membered ring, but all the atoms in the ring are carbons. Right,
okay, so that carbon there is being bonded. Syn addition.
Yeah.
Or syn reaction.
Syn additions. Yeah. Right. Similar reaction, but no oxygen. Right. Where, like you said, this carbon here is that carbon right there being added.
Okay, awesome. Good.
Okay. Oh, okay. Now these last two here, we went over it in our last session. Do you recognize the reagents?
Yeah. Yes, I remember because the peroxide. I was like really lazy when I was copying this down in class. Yeah, I did not copy down the second step just so I have it for completion because the peroxide is the important part here. OH and THF. Okay. Okay, so I remember the peroxide. Is it anti-Markovnikov?
Yeah.
Yes. Okay.
Anti-Markovnikov, and the peroxide makes it anti-Markovnikov. Right.
And then does it make it a single bond?
A single bond to what kind of functional group?
An alcohol.
Alcohol. Right. Yes.
I remember because it's the mercury and the other one, which is that one, do the alcohol. It's just adding an alcohol, whether you're doing the substituted or the less substituted.
Right. And
So then it
anti-mark,
would be the first one, the first carbon.
yeah, like that.
Yes.
Nice.
Wait, did I do this? Wait, was I doing this correctly? That is not what I had drawn because what was I even? Oh, I got confused because I thought it was hydroboration or whatever.
Oh, this is
but-
hydroversion oxidation. Yeah,
No, I was looking at something else.
hydro.
I was looking at something with like two ketones before I got on the call with you, and it was a different reaction. Or no, it was for alkynes. So I think I got confuzzled because I think that one was a little
Alkyne to two ketones.
different. Yeah, something like that. I don't know what I had drawn. I'll figure it out. Right now, everything just needs to be correct, and then it's good stuff. Okay, so let me put all of these in line bond so that I can be pretty here. H. Oh, that's kind of satisfying for the ozone to draw in line bond because like one has the carbons and then one has the hydrogens. It's
Oh,
just like they match.
oh yeah, huh? Yeah, two hydrogens here, two methyl groups here for the ozone analysis.
How do you even draw carbon dioxide in line bond? It looks weird because then it's just like it would just be a bunch of double bonds going together. It has to be linear.
Yeah, something like this, but like you
That
can't
looks horrid.
you have to make it, put a dot right there to show that dot
Is the
is
carbon.
yeah.
Okay. Nothing there. That one's good. That one's good. This one. Okay, that looks fine. And I wasn't okay. Wait, let me make sure because I like did palladium because I wasn't sure if he put that on here, but he didn't. We have 1, 2, 3, 4, 5, 6, 7. Oh, wait, no, wait, yeah. Is the mercury one on there?
Yeah,
Yeah.
it is the very last
Oh, we
one.
haven't done that one yet.
Yeah,
I'm like getting all
right.
excited.
What is the reaction of the last one name? We know it's Markovnikov, which is the opposite of the anti-mark one, but what is the specific reaction name for it?
The mercuration, hydromercuration,
Oxymercuration,
oxymercuration, something
demercuration.
like that. Oxydemercuration.
No, oxymercuration, demercuration. Oxymercuration, demercuration. They go together.
Okay.
Oxymercuration, demercuration.
Yeah, is that like the whole name
Yeah, that's the whole
or
name. Oxymercuration, demercuration. That's the whole name.
okay.
Whole name. Oxymercuration, demercuration
Did
reaction.
we do can you scroll back up a little bit? I want to make sure I have mine in the right order on here.
Yeah.
All right, so that was the oh, okay, good. Okay, I have that one there. Okay, I'm just gonna yeah, that one's fine.
And let me draw out the products for that. Since it's Markovnikov, we want the alcohol on the more substituted position. So that's why I'm putting this alcohol on this carbon here, which is the more substituted carbon of the alkene.
Okay, perfect. Yeah. Then it would just be
And after you write this chart down, I'm gonna give you practice problems relating to what we just did, and then you'll finish out with the reactions here.
okay, awesome.
Uh-huh.
Wait, what the I think I gotta like never mind. 1, 2.
And I'll actually
3.
include chiral centers here because these products here like there's no chiral center at all. Like for all the products there's no chiral center.
That's crazy.
Yeah. Right. So that's why the wedges and dashes here, that's why I said it's optional. But if there was a chiral center, you do need to include wedges and the dashes, which is why I put them here in the first place, because some problems will require you to put wedges and dashes if they're chiral centers.
Okay, that's good.
And also the sin addition as well. Yeah.
That is okay, the chicken foot looking one is the
Right. And let me put a
mercuration.
note here for the HIO4.
And then the BH3 is that one. Okay, so then I'm good.
Yeah, HI4 reacts with bistanols and diols, not alkenes. Right.
Right. That's like such a random like side note. Like,
Yeah.
we're like doing alkene reactions and then it's like alcohols. I'm like, okay.
I know.
All right. That is good for that.
Mhm.
The
Okay.
spectroscopy stuff,
Yeah.
I don't know how much of that's there's probably gonna be some on the test. That'll make sense if I just read it, right? Is there anything you need to like explain to me or if I
No,
like
no, no.
read
If you
that?
read through this, then it will make sense. Like this
Okay.
explanation
Wow,
thing.
you're amazing. Thank you.
Yeah, no problem. Wait, oh, dude, this one is just going over 22. Like it didn't go over the other problems.
That's okay. I hope it'll make sense.
Uh-huh. But if it doesn't make
It'll
sense,
probably be like one problem.
yeah, for mass spectrometry. I know, I
He's
know.
for the number of mechanisms he gave us, like what?
Yeah, it's too much.
I know it's gonna be mostly mechanisms. I can feel it. Just like I
Yeah.
thought I was like over focusing on chirality for this last exam, and it was like the whole test.
Uh-huh. That's so good.
And I was like, woo. Okay, I do have actually one question about my
Yeah.
test. For
Uh-huh.
number 4, I wasn't sure if I did this right. So
Yeah.
I drew the 4 isomers, the 4 different ways that they could be drawn. Sorry, I just like totally made you switch out of that.
Uh, wait.
And I feel like he like circled the wrong one that I was talking about.
This one.
Sorry. There's so much stuff going on.
No, it's okay. It's okay. Oh.
I just texted it to you.
Oh, you texted it. You texted it.
Sorry.
No. It's okay. It's okay.
I scanned it on my phone.
Let's see. Here you go. Yeah. Okay. Yep. Boom. Boom. Save. Upload. Okay. Yes. What?
I love it when it
Oh,
does
here.
that.
I was in a subfolder.
No, it's like gets crazy sometimes.
Yeah. Okay. Let's do this. Okay, number 4.
Yeah, number 4. Look at all those tens. So nice.
Oh my
Okay.
god. 10. Perfect.
And then, okay, so for this one, I circled the top one. I said that one would be more stable because there's no axial strain with the hydrogens because they're equatorial. And then
Great.
he marked up the other one. And I'm like, that's not the one that I circled. He marked up the bottom one. That's where his red pen is on the bottom. So, yeah. So I'm like,
Oh, this one here.
that one does have axial strain.
Yeah, I think this red like line here is showing the axial strain. Did he circle this as the correct answer?
No.
No. Wait.
I circled the one above as the one that
Yeah.
I was talking about.
Right.
And he marked up the one that I didn't circle. I just drew all of them to show them.
Oh, I see what's going on now. Yeah. He thought you put this as the answer.
I think that's what he thought.
Yeah.
Which one is the most stable? Like,
Yeah.
I'm correct, right? The like equatorial cis would be the most stable because the trans ones all have like the axial ones all will have some strain on for the other ones on the left, the trans. The two, because those two are the 2 cis isomers, and then the other 2 are the 2 trans isomers, I think. That I did correctly. I thought.
I see. A 1,3 trans isomers. That's like okay. Or Oh, yeah, because both of these are trans, both of these are
Mm-hmm.
cis.
Mm-hmm.
They could exist either in this form or in
Mm-hmm.
this form right here, where both are cis, going axial to each other.
Right. So that'd be like the most strained. And then the other one, the other cis would be like the least strained.
Yeah, I don't like how this question is worded here because there's two trans and two cis here, right?
So I drew it correctly, right?
You drew it correctly, right? This is the least energy overall. This
Mm-hmm.
is the most energy overall,
And
and
then
then
where do the
this is,
other, those are like equal,
yeah, those are equal
right? So
energy.
those are in the middle. So like,
Right.
then how would you say that? Like, I don't know what, should I ask him what he thinks the correct answer is and then tell him my like thought process? Cause like hypothetically, I could probably get points back. Cause that's
Yeah,
the least
yeah, yeah, yeah,
strange.
yeah,
The
yeah,
one that I
yeah.
circled is
This
least
is
strange.
yeah, yeah. This is the least strange. This is the most stable here, the one that you circled.
Yeah, it's not like is it cis or trans? It's like is it equatorial cis or is it axial cis that we're talking
Right, right.
about? And I
Because he
said
needs to be more
equatorial.
specific.
I literally wrote equatorial on
Right, right,
there.
right.
So okay, so
Yeah.
I'll ask him about that one.
Uh-huh.
Actually, I'm not gonna ask him
And
that
your chairs
one.
look so nice.
My what? Oh, thank you. I told you it like came naturally to me.
Like
Um.
most students, they do some kind of like something like this.
Oh man, they like draw an actual chair.
Yeah.
Thank you. No, it's so
Uh-huh.
cute.
Yeah.
And then okay, so I missed a couple. Oh, I do have okay, so for question 5, so
Uh-huh.
this was the one I was trying to describe to you that I couldn't tell you about. The
Yeah.
bottom left, part D on the first carbon. No, sorry, part oh, he labeled two of them
Oh,
D. The other D.
no, this one,
um,
this one. Oh, bottom left, bottom
yes.
left, bottom left. There.
So obviously I missed a couple chiral centers, but whatever, better than getting points off for labeling the wrong ones.
Right, right.
That's like obviously chiral. There were just so many. I think I just lost count.
Wait, you made a question mark here on the
I
exam.
did because I wasn't sure. I wanted to know when I looked back at it why I wasn't sure about it.
Oh, I see. To look back, I thought like you just did that to show professor. You're so confused.
I was that too.
Yeah,
I'm not
yeah,
gonna
yeah.
lie. So for this one, why is I wasn't sure how to order the groups.
For
So
this
because you
one right
can
here,
see, yeah, for
or this one, the
the
left
left
one.
one, yeah, the left one.
Okay. So when you see cho, what functional group does that represent? Cho.
A car. Oh crap! That's a carbon bonded to alcohol, huh?
Carbonyl.
Um.
Aldehyde. Whenever you see cho, that's an aldehyde. This is the cho. C H
Okay.
O.
Oh, so it counts as two. Oh, so okay. So it counts as two oxygens, and
Yeah, it
that's
counts as
why
two
it's the
oxygens.
other way, which
Mhm.
would be 1, 2, 3, which would be S flip to R, not R flip to S. Okay.
Right, because this is one. This is
That's
two,
1, 2,
three.
and then 3.
This is S flip to R.
Okay. Cool. And then yeah, I just missed. Oh, I literally only missed one other one. I only missed 2 chiral centers and then I labeled one wrong. That's not bad considering the number that we had to label. I'll
Yeah.
tell you. Not there was a lot on there. And then number 6, I literally look at this is look at what he said. I put incorrect name should minimize the numbers on number 6, and he's like, yes.
Okay, they should minimize the yo.
And then I promptly answered the question with the wrong thing. I totally knew what I was talking about. I meant to say that they were the same and that they were stereoisomers.
Trans one
But I
four
did not say that. I just said that they were the same and they're not because he literally circled cis and trans, which is so true. They are in fact cis and trans. So that was
right.
just an oopsie mistake. 7 also wasn't exactly sure what I was doing, but got 8.5 points for it, so that's solid.
Oh my god! Like this is so good. Like how you labeled like this is the incorrect name, right?
Thank you, thank
Right, right.
you.
Because Mascal, I don't know. I don't know if you heard that professor at UC Davis, Mark Mascal for 118B. He's
Mm-mm.
kind of worse than the series. Like his averages are lower than the series. He's new, right? He taught 118B last quarter.
I better not get him this year. I will not be taking it. I will wait. I will
No,
wait.
you're ready for him though because his question was like, which one of these is the incorrect name? Like, and he gives like answer choices like this, and then
Uh-huh.
like you figured it out like correctly. So
That's
you
because
got
we
to
had
say
homework questions like that where it was like figure
oh
out what's wrong.
Yeah,
And
dang.
well, also when you're trying to draw it, you're like, this doesn't make sense. It's literally named incorrectly because they're the same
Yeah,
thing.
I know.
Well, they're not the same thing. They're
I know.
sister
No.
strands. And I
People
just
just
forgot
try to
about
look
that.
at it and said, "Oh, that looks right," but then when you draw it out, it looks wrong.
No, it's not. And I was like, I was gonna draw chairs, and then I was like, I forgot how to draw the pentane chair. Okay, and then what is going on with number 10? Just
Number 10.
explain that to me real quick, because I
Okay.
like my carbocation understanding, I think, is not great,
Mm.
obviously.
uh, draw the structure of the carbocation, right? That would result in each of the following alkene reactions with acid. H plus. It could be strong acid H3O plus, H2SO4, HCl, HBr, any strong acid, right? Which is
Okay.
represented by H plus here.
Okay.
Strong acid, right? And if it's a strong acid, it's gonna look for the strong or any kind of base to react with. And then alkenes, you can think of them as a base and a nucleophile.
Okay.
Right? Because bases and nucleophiles tend to have electrons to attack something, to attack an acid or an electrophile.
Yeah.
Right? Has electrons. Right? And then there's a cloud full of electrons in the region of the double bond because the double bond represents a lot of electrons, 2, 4 electrons.
Yep.
Right? Now, carbocation, carbo meaning carbon, cation meaning positive charge.
Yep.
Right. And then we went over the stability of carbocations. The more substituted or the more hyperconjugation,
The more stable.
the more stable, right? Where tertiary is.
I asked him such a good question today. It took him like a whole minute to answer.
Oh, really? What was the
Yeah.
question?
It was so the reactions happening with the alkynes or whatever, and he's like, you would expect this to be like a 25-75 mixture, but it's 35-65. Why is that? And then he said that it was because the one on the left, it was like a carbon with like 3 methyl groups, and then they split up or something,
Yeah, yeah.
And so
The
it
one
was
that.
like there's only one spot. So, but this was the answer. So I was like, okay, well, if you're saying that the tertiary carbon is more stable, then why isn't that not the majority in the mixture? And so it like took him forever. And then he finally told me, he's like, well, there's only one spot for it to bond because it's taken up by the other 3 methyl groups, whereas the primary one has 3 spots for it to bond. So it's more likely, but the stability adds the extra 10 to the other one. And I was like, oh.
Yeah, the
okay.
stability, right.
But it took him a while to answer.
Yeah, good questions, good questions.
I know. I was like,
Right. Wait. So for A,
yeah, you just have to show me one and then I figure out what I
okay. Well, I'll show you
something I
A.
obviously just didn't study.
Oh, actually, he was kind of nice for this kind of question because there's no there's no shifts here, no shift, no shift, no shift, like no hydrate shifts.
Did
Oh
I
wait,
do
no,
that? I
going
thought I
over
knew I
C.
wasn't supposed to be doing that.
Uh, yeah. There's no. I'll show you why. I'll show you why when I go over A. But I want to go over C with you as well. I want to go over
Okay.
C with you.
No
Right.
worries.
Okay. So we
I'll
know
write this
that.
on the back. There we go.
Yeah. The mechanism.
Yeah, no, I just want to write what you're writing down on my test. And I was like, I got space.
Right. So the carbons here of the alkenes, they're going to be the nucleophilic or basic carbons, right? Which position do you think is going to be more stable, holding the positive charge with the positive charge?
The left of the two, yeah.
The left of the two, right? If we want a positive charge there, do we want this carbon to lose a bond or gain a bond?
If we want the positive charge, we want it to lose a bond.
Lose a bond, right? That means the other side has to gain a bond, and the other side is going to attack the hydrogen.
Wow, that's totally not what I did. This makes total sense to me. I think I figured this out after the test when I was doing the homework over the weekend.
Right. H pluses never attacks. It can never attack. Positive charges.
Oh no, I was trying to show oh yeah, you are right about that. I did draw an arrow going back the other direction. I meant to say that the double bond is attacking the hydrogen. Oh crap.
Wait. This arrow here is correct where the double bond attacks the hydrogen, but the arrow from the hydrogen is never good, right?
Wow, I booted up my laptop and it rejoined me to the meeting automatically. That was crazy. Okay.
Oh,
And I
dang.
was like thinking I was gonna have to go click the link again. Okay, sorry, continue.
Uh-huh. Right. So these arrow pushing mechanisms, they always start with something negative charge with electrons. This hydrogen here has no electrons, so there's nothing to move there. Like these
Oh,
arrows
okay.
starting from the hydrogens are not good, not good. We
You,
wouldn't want
you said those are wrong.
that. Right. And then once that happens, I'm gonna draw out the hydrogen bond specifically, which is this hydrogen right here, right? And
Okay.
this bond came from that double bond right there, right? That double bond is no longer here because it got moved to make this bond right here between this carbon and hydrogen right there, right?
Okay, so this is going and attacking that. Okay.
Right. Because let me
I
circle
like
that.
to draw out the hydrogens too.
Yeah. Right,
When
right. The
this is
hydrogens.
happening.
Right,
Yeah.
like the mechanism to show what's.
I know, I'm like, otherwise you can't see what's happening.
Yeah, right. Because I think when professors do it, they teach you like where they assume you know like where it's going, the invisible things, invisible atoms, right?
Nah.
Right. But we notice here. Let me also draw out the hydrogens on this carbon. There's two hydrogens here, which I'm gonna draw in black, which are these two hydrogens in black right here.
Okay.
Notice how this
Yeah.
carbon here has 4 bonds at the beginning, 1, 2, 3, 4, and it still has 4 bonds, 1, 2, 3, 4.
Yeah.
Which is why it's neutral. But the left carbon here, it used to have 4 bonds, 1, 2, 3, 4, no bonds to the carbon, but it
Which
lost
is why
the
it's a
bond.
cation now.
Yeah, which
Okay,
is
and
why
then
it's
the
a carbocation.
hydrogen went to the one on the right. Okay.
Yeah, the hydrogen went to the one on the right in order for us to create that positive charge on the position we
Okay.
wanted, right?
And
then
then
that
that's
one came from that double bond right there. That's that, right?
wow.
And in this case, we don't have to worry about the hydride or methyl shift because it's already at its most stable position, right?
Right.
But if this was secondary and this is tertiary, then there's something else that we gotta do, like a hydride shift or a methyl shift.
Yeah, should I be worrying about that for this upcoming exam? Like that's still stuff I have to do, right? Like the hydride and the methyl shifts for the mechanisms.
I saw in his lecture notes he did go over hydride shifts, so worry
Okay,
about that as well.
so probably just for when I have to show the mechanisms, but if I'm just doing the products, then don't need to worry about
Right. Well, if you do the products, worry about that too, because if you just put the group on the more substituted carbon of the alkene, there's a chance for it to shift to the other side. Right.
that. Okay.
An example would be something like this. Wait, what would the product look like for this reaction?
Okay, so the bromine would go to the carbon on the left of the double bond.
This one right here.
Yeah, right.
Right. So that was the thing that I told you to be careful about. Right. A good thing we're going over this. This
Oh my
right
gosh,
here
did I
is
just do it
actually
again?
minor. Yeah.
Cut myself. Okay.
Because think about the mechanism here. To predict the product correctly, think about the mechanism. This is a strong acid, HX. Which carbon would grab the H? Which one do you think is going to grab the H?
The one on the right?
Yeah, the one on the right.
Because that goes to the least substituted.
Yeah, and we're going to kick out this bond onto the bromine right there. Right? And that creates this carbocation on the left, the more substituted one.
Right. And then the negative would attack the positive, right?
Br minus will float around, but before that, we gotta look out for something. We gotta look out for a hydride shift.
And then that would switch over, right?
Right, but then we can't do this arrow. What's the problem there? What's the problem with that arrow?
Right,
it
has a hydrogen already, and it's full. It's sp3. Right? No.
Yeah, it is sp3. It is sp3, right? but then what do arrows represent in mechanisms? What did it start
electrons.
with?
It's going the other way.
Yeah, no electrons there. When you want to draw the hydrogen shift, you have to explicitly draw out that invisible hydrogen right there.
And then it just
move this whole thing, the bond with the hydrogen, onto that carbon right there.
Okay, yeah. Definitely need to practice this because I just wiped this from my mind since the weekend.
Right. This will show up on the exam, I think. This hydride shift.
Yeah, no, he's definitely gonna put it in a question. I'm gonna like mentally write the first thing down on my test, and then at the end of the test, make sure I like didn't miss it on a problem.
Yeah. Right. And then
okay, good.
The Br minus here will attack that carbocation to give you the major product here.
Okay, yeah. So kind of like a helpful thing if I like don't do the whole mechanism is first just look because what is it? Which are the ones that can't do hydride shifts?
HX.
What's it called?
whenever you have a mechanism
Which
that forms a
reaction?
carbocation intermediate, right? So reactions with
Oh, so the ones that are one step. Oh my gosh. I forget he
multiple
was
steps,
telling us
multiple
about
steps.
this. No, yeah, but the ones that are one step cannot have methyl or hydride shifts. He
Yeah,
was talking to us about this.
right.
I say that like you were in class. You were in class.
Wait,
I'll figure it
it's
out.
not all the reactions because oxymercuration, demercuration, and hydroboration, oxidation, they have a lot of steps. They don't have
Yes.
any shifts at all. They have no
Okay.
carbocations,
Okay.
right?
It's
But
just because there's no carbocations. That's what
yeah,
it is. You're right.
right,
Yes.
right.
Of course, right. Yeah.
Whenever there's a carbocation, you always gotta look out for hydride shift. That's
Okay.
always the one. Right. Now let's go over C, the one that I wanted to go over with you.
Yes.
Okay, now which one of these, let's say, carbons of the alkene, do you think is gonna be the most stable carbocation?
I mean, they're all the same, right?
There's two that are the same and two that are the same. So there's two different unique ones.
Right. Yeah.
Right, let me draw up both of them for you. So that one or this one?
Which one's more stable?
Yeah, which one is more stable?
The top one, because it can swap over.
Yeah, top one because it could do resonance, right?
Yes.
This is a secondary allylic carbocation.
Allylic. We were talking
Right.
about that today. The allylic positions.
Allylic position, right? Which is one carbon away from the alkene.
I love how we're talking about that today, and this was like kind of relevant for what he tested on us on last week.
Oh
Okay.
yeah.
It's whatever. It's okay.
Wait, this was on the exam last week with the allylic position?
Yeah, but we learned about it today.
Oh, what the heck?
I know. It's fine. I got a 93. It's okay.
Yeah. That's good. Right. We see here, this positive charge here is delocalized. It can move around the molecule. It has more breathing room, more stable.
Mm-hmm.
Right. This carbocation here is stuck, localized, no breathing room, right? Because it's not allylic. The sp3 roadblock cannot move there. Right?
Yep.
Less stable. Right. Nice.
Okay.
Oh yeah. We didn't go do the problem here. If we want it there, then we gotta use this carbon to attack.
Okay. Let me.
Yeah. That's it.
Okay. Cool. Are these uploaded to? They'll be uploaded to the drive.
Yeah. Yeah. I can upload this to your drive as well, and I also upload this to the office hours school community because these are like the office hours one, right? These are not counted towards your 10-hour session package.
Okay,
right.
Awesome. Yeah, I can find it there. I was just wanting to make sure where it was because I was like, oh, okay, cool. Yeah, no, that's great. I should let you go.
I'll see you this Saturday. We have 2-hour session this Saturday, right?
Yes,
7:30
and we
PM.
moved it. Yes, 7:30. And are you having office hours tomorrow?
Yes, I will because I don't have that much exams. I do have one exam tomorrow, which I'm gonna be studying like for tonight, but I do have another exam on Thursday as well, but it's not as big as it was today. 3 exams.
That's crazy. Yeah.
I
wow.
know.
That's just like insane.
I got like 2 exams next week too. Like I had 2 last week.
What? How do you have exams every week? That sounds horrible.
Back to back. I know.
Do you get a break or then boom, just like it's over?
And then we do get like a 1 or 2 week break and then finals after that 3 weeks. I know.
Horrible. Wow, your midterms last like 3 weeks.
I know. The good thing is that they tend to overlap because you know how like the classes are very similar. It's not like chemistry and like
math,
geography or math.
Yeah, biology.
Like biology. Yeah. It's all related. They are connected. Yeah.
Then they're helping with each other, so that's
good. Right.
Okay. Well, good luck studying, and yeah, I'll definitely see you tomorrow because I'm gonna be like, help me with the mechanisms.
Yeah.
Thank you so much.
No problem, Katia. See you tomorrow.
Bye. See you tomorrow.